Welcome to aminacademy.com. In linear programming, let us discuss about formulation of LPP, that is linear programming problems. Formulation of the linear programming model consists of three components. First one, the decision variable. Second one, the environment, that is uncontrollable parameters. Third one, the result, that is dependent variables. Linear programming model is composed of the same component. Here, the decision variable here constraint both tends to objective formation. Further, we'll discuss about terminology used in linear programming problems. First one, component of LP problems, that is every LPP is composed of decision variables, objective formation and constraints. Second one, optimization. Linear programming attempts to either maximize or minimize the value of the objective function. The aim of LPP is to obtain, maximize or minimize the values. Third one, profit of cost coefficients. The coefficient of the variable in the objective function express the rate at which the value of the objective function increases or decreases by including in the solution one unit of each of the decision variable. Constraints. The maximization or sometimes minimization is performed subject to set of constraints. Therefore, LP can be defined as a constrained optimization problem. They reflect the limitations of the resources. Input-output coefficients. The coefficient of constraint variable are called the input-output coefficients. They indicate the rate at which the given resource is utilized or depleted. They appear on the left side of the constraints. Capacities. The capacities or availability of the resource. Various resources are given on the right hand side of the constraints. Capacities means machine capacity, labor capacity, like. Now let us do an example problem to understand this concept clear. Look at this example. A firm produces three products. These products are processed on three different machines. The time required to manufacture the one unit of each of the three products and the daily capacity of the three machines are given in the table below. Here machine 1 and 2 and 3. Here product 1, 2 and 3. Time per unit, minute. These are. Here machine capacity, minute per day. These are the given things. Here it is assumed that all the amounts produced are consumed in the market. Formulate the mathematical LP model that will maximize the daily profit. Now, it is required to determine the daily number of units to be manufactured for each product. The profit per unit for product is 1, 2, 3 is rupees 4, 3, 6 respectively. It is assumed that all the amounts produced are consumed in the market. Formulate the LPP. Now, first one, express the feasible alternative mathematically in terms of variables. Feasible alternatives are those which are physically, economically, and financially possible. In the given situation, feasible alternative set of values x1, that is we have to do let x1, x2 and x3 are feasible alternatives, that is variables. Now where x1 and x2 is always positive, greater than 0. Now maximize the profit, that is z equal here 4x profits of first profits of the first product is 4 rupees, second product is 3 rupees, third product is 6 rupees. Therefore we have to maximize the profit like 4x1 plus 3x2 plus 6x3. The profits are product per machine 1 is 4 rupees, machine 2 is 3 rupees, machine 3 is 6 rupees. Now we'll make constraints we'll do now. Constraints 2x1 plus 3x2 plus 2x3 is lesser or equal to 440. Like you have to do 4x1 here 0 and 3x3 is lesser or equal to 470, like third one also. Then we can write the constraints 2x1 plus 3x2 plus 2x3 is lesser or equal to 440, and 4x1 0x2 because it's not available, and 3x3 lesser or equal to 470 rupees. Here 2x1 plus 5x2 and 0x3 is lesser or equal to 430. Here these are the constraints. This is maximize the profit. That means you have to solving this and substitute the values of x1, x2, x3, and we can find the maximum profit of this plant. Next problem. Example, a factory manufactures two products A and B. The manufacturer 1 unit of A 1.5 machine hours and 2.5 labor hours are required. To manufacture product B is 2.5 machine hours and 1.5 labor hours are required. In a month, 300 machines hours and 240 300 machine hours, 240 labor hours are available. Profit per unit for A is rupees 50 and B is 40. Formulate LPP. These items are given in table form. Then we can formulate LPP. Now let X1 number of units of A, number of units of machine A, manufactured per month. X2 is number of units of manufactured by B per month. Now objective function, that means maximize Z equal maximize Z 50x1 and 40x2. Here profit per unit is 50 rupees in a machine A and 40 rupees for machine B. Therefore here maximize the profit, that is 50 into x1 plus 40 into x2. Constraints now, subjective constraints. Here 1.5 machine hours x1 and 2.5 manpower x2, that is man hour 1.5 1.5 x1 plus 2.5 x2 gives 300 hours, and labor hours this is machine hour for labor hours 2.5 x1 plus 1.5 x2 is lesser or equal to 240. This is labor hours. Look at here, labor hour is 2.5 and for A machine B is 1.5 for machine B. Like machine hour is 1.5 and 2.5, total hour is 300, total hour is 240. So we made non-negativity constraint is x1 and x2 is greater or equal to 0. So we formulate the LPP problem from this by solving these equations and substitute this x1 x2 values in Z, we can find maximum profit. We have done. Please subscribe our YouTube channel.